So this one is classified paper 6, topic electricity experiments related to voltage, current and resistance. That is question 3 of the classified paper, which I already shared with you. So the student is investigating a circuit which contains different lamps. As you can see, lamp X and Y are there, which are connected in series to an ammeter. There's a power supply and an open switch. On figure 3.1, draw a voltmeter connected so that to measure a potential across lamp X only. So we want to measure only a voltage across X. So you can use screen annotation, how the voltmeter should be connected across X. So voltmeter should always be in parallel. So you can connect it in parallel up or down. It does not make difference. That's right. Then student use a ammeter to measure the current in the circuit. Record the value for the current in the circuit. What is this value? The current. You can use the chat. You can use your mic, or you can use the screen annotation to complete this. So 0.34. Yeah, that's right. Point, because like 10 lines are there, spacing or divisions are there for 0.2. So each is 0.02. That's why this will be 0.3234. And unit of a current is ampere. Then student use a voltmeter Vx across lamp and voltmeter Vy across the lamp Y. You have to state the reading of voltage at X. This one is voltage at X and 3.4 is voltage at Y. You can use the screen annotation to complete what is the value for voltage at X. So that is 1.2 volts. And what about voltage at Y? So voltage at Y is equals to 1.9. Then she then measure the potential across both of the lamps in series. Like to measure the potential or a voltage across both of them, so she should connect a voltmeter in parallel to the series combination to get the total voltage across from X to Y. So what is the voltmeter reading now? So it is 3, but don't write only 3. You should write 3.0. So it should be 3.0. And the unit is volts. For those who just joined now the session, this is question 3 from electricity experiments, classified paper 6. Then students suggest that Vs should be equal to Vx plus Vy. So student is saying that state whether the readings support this suggestion. So what was the value for Vx? The value of a Vx was 1.2. And the value for Vy was 1.9. And value of Vs was 3. So student is saying that Vs should be equal to Vx plus Vy. That is the student suggestion. State whether the readings support this suggestion and justify your statement with reference to the result. So what is the value of a Vs? The value of the Vs, we got 3. And what about Vx plus Vy? Vx was 1.2 and Vy is 1.9. So when we add them, it will be 3.1. So can I say 3 is equals to 3.1? Yes or no? So we can say yes here, and reason is that even you can compare the percentage difference. When you measure the percentage difference, it will come out less than 10%. So we will say statement matches the result. So statement match the results. Or you can also say statement is true or statement is correct, and justification you will mention Vs is because with reference to value, so Vs is 3, where Vx plus Vy when you add them 1.2 plus 1.9, which is equals to 3.1. So you can say 3 is approximately equal to 3.1. Is it clear, this one?
Yes, sir, clear.
Then the next part, calculate the resistance R1 of a lamp X. Use your reading from B and C1. So look, for paper 6, you don't have to memorize any formula. You just have to use the variables which are given. So we have to divide Vx by Is. So what was Vx? Vx was 1.2. This was Vx. This we get the Vx, that was 1.2 here. And what about IS? IS is the current which we got in the beginning of the question. That IS, that was 0.34. So we just have to 0.34 amperes. So we just have to divide these two values. So the voltage was 1.2 and the current was 0.34. What's the answer for this? So that is 3.5. The circuit components are arranged so that lamp X and Y are now in parallel. An ammeter to measure a current in lamp X only, and a voltmeter across the two lamps. Draw a circuit diagram of this arrangement. You can use a screen annotation, complete this part. Any part of a screen you can use to draw your circuit. Lamp X and Y should be in parallel to each other. And there's no cell, so you have to use a supply symbol. Basil, this is not correct. Why this is not correct? Because this is not the circuit symbol for supply. You are drawing a cell. It should be a supply. And label so the two lamps should be in parallel. Then ammeter just to measure a current in one of the lamp in X. Because ammeter measure the current in lamp X only. Yeah, that's right. This was correct when you draw the ammeter here. It was right. And you need a voltmeter to measure voltage across both of them. So this is fine. And so even this is fine. This is not wrong. Even voltmeter you can connect it here, or you can connect a voltmeter above. Even I can connect across one of the lamp. That will also be fine. But if I connect a voltmeter in this manner, this is wrong. Why this is wrong? Because voltmeter should be only parallel to the lamp, not lamp and ammeter, both of them. This will be considered as wrong. If you want to connect a voltmeter, it should only be connected parallel to the lamp. And there are two lamps in the circuit. As you can see, there are two lamps in the circuit, but you draw only one of them. So this is also a mistake. As I mentioned, lamp X and Y should be in parallel. If you connect voltmeter like this, what we consider that ammeter does not have any voltage. So that's why this is acceptable. Like, but the thing is, whenever you want to connect a voltmeter should be parallel to the lamp only. This is only acceptable if when we consider the ammeter is having a negligible resistance. And there should be two lamps here in the circuit, Basil. Is it clear, this one? So you just have to connect two lamps in parallel. An ammeter to measure current in one of them, a voltmeter to measure the voltage. That will be same for both of them, and then a supply. Student set up the circuit described in E1 and she measure and record the current in lamp X and the potential across lamp X. She then calculate the resistance R2 of a lamp X in parallel, which is 8.3. She noticed that lamp X is very bright in parallel, but it was dim in series. Suggest how the temperature affects the resistance of a lamp and justify your suggestion with reference to R1 and R2. What was the value for R1 when we calculated the value for R1? It was 3.5 for us. So R1 was 3.5. So this R1 was 3.5 ohm and R2 is 8.3 ohm. These are the two resistance. And now what's the question? The question is student note, and this was lamp X. Both cases, like this is the same lamp X is there, but when lamp X was connected in series, it was having a resistance that because the resistance of a lamp changes as we use it for a longer period of a time, current produce a heating effect. So resistance does not remain constant. It increases. And if you remember the IV graph for a filament, if the current is on y-axis and voltage on x-axis, so the slope decreases, shows that the resistance is increasing. This is the IV graph for a filament lamp. So now what happened? She measured the resistance of lamp X. So she measured the resistance of lamp X in the first circuit, it was 3.5. But the next circuit, like when she connect in parallel and lamp was already in use, so the lamp become hot, the resistance of a lamp increases and new resistance is 8.3. The question is how the temperature affects the resistance of a lamp. So what is the relation here between the temperature and resistance of a lamp, and justify your suggestion by reference to the value of R1 and R2. So what we can say, when it was first thing, R2 is more than R1, it means the resistance has increased with temperature. So from this value, what we can say, we will say as R2 is more than R1, so it shows resistance increase with temperature. So if a temperature of a lamp increase, the resistance will also increase. Is it clear? The last part.
Yes, sir, clear.
One more question from the same topic, electricity experiments. A student is investigating a resistance wire. She uses a circuit as shown. So you can see a circuit is there. On a figure, draw a voltmeter connected to measure a potential across P and Q. So we want to just measure the voltage across P and Q. How a voltmeter should be connected? You can use screen annotation to connect a voltmeter. So voltmeter should be in parallel. And when you're drawing a voltmeter, like this is fine, but because the circuit symbol should be correct, so this, when you connect, better make a circle first and then the lines which are joining. You can use right now because it's a screen annotation, so you won't use a ruler, but in exam, use a scale, draw these lines and then accurately draw the voltmeter. Like this line should not cross the voltmeter because the circuit symbol should be correct. Circuit symbol for a voltmeter is a circle with letter V. Then a student connect the crocodile clips. These are the clips. Crocodile clip is there, and the student is changing the position of this crocodile clip and record the length is 90 centimeter. Record the voltage and the current. Read and record the table for voltage and current. So what is the voltage here? What is the voltage value? 2.6. And what is the current value here? The voltage is Current is 0.36. Yeah. So 0.36 and 2.6. So what you have to do, you have to just complete there. So you have to record this value and you have to complete the column heading. So this should be voltage ammeter, and this was 2.6 and 0.36. Now complete the value for the resistance. How to get the resistance? Voltage divided by current. So 2.6 divided by 0.36. What's the answer for this? 2.6 divided by 0.36. 7.2. And then 2.5 divided by 0.52. 4.8.
4.8.
And then the last value, 2.3 divided by 0.71.
3.2.
3.2. Then the last column you have to do R by L, means resistance divided by length. So you have the resistance 7.2 divided by 90, 4.8 divided by 60, 3.2 divided by 40, and complete the last column. So 7.2 divided by 90, 4.8 divided by 60, and the last value 3.2 divided by 40. 0.01, 0.08. Okay.
Sir, it gave me 0.017.
So 0.017. Can you check? It was 3.2 divided
Yes.
by 40. 3.2 divided by 40. Can you check again? It is 3.2 resistance divided by
Oh, sorry,
length.
mister. I made it 0.71.
Yeah, because it's resistance and resistance over length. Yeah, 0.08 is the right one, because resistance over length for any wire should be constant. Like resistance per length is a constant thing. That's why I was sure that it should be 0.0. Then we did R by L, we already did that. Use your results in table 3.1, calculate the resistance of 25 centimeter wire. So how we can calculate the 25 centimeter wire? You can simply look, you can use a ratio here to work out, like if we have because resistance and length are directly proportional. For example, if we have a length of a 90 centimeter, it was having a resistance of 7.2. So if we have a length of 25 centimeter, how much should be the resistance X? Cross multiply. 25 into 7.2 divided by 90. What's the answer for this? 2.0. So that will be 2.0. Is it clear? And even you can use any value. It does not make difference. For example, I use 90 centimeter. Example, another student use a second row. That ratio between resistance, say length is 60 and the resistance was 4.8. So 60 is to 4.8. If I have 25, this will be X. Cross multiply. Again, you will get the same answer as 2 ohm. It won't make difference. 2.0, yeah, that's 2.0 we'll write. So it won't make difference because we are using a proportionality ratio. That's why it will always be give the same answer irrespective of what value we take. Suggest one reason why different students carry out the experiment carefully with the same equipment may not obtain identical result. Like for example, student A did the experiment, he was getting 0.08, but student B did the experiment, he might get 0.09, another value. Looking at this circuit, can you identify what might be the mistake, like what might leads to a different values? The answer is related to the circuit. When you look at this circuit, Yeah, that's right. The crocodile clip. Because what happened, student may not place the crocodile clip. The placement, yeah, that's the right answer. The placement of the crocodile clip, or difficult to judge the exact position of a crocodile clip. Like we are saying this length is example 90 centimeter or 60 centimeter or 40 centimeter, but it's hard to identify the exact position of a crocodile clip as it is not having a regular edges. So the answer here, the position of a crocodile clip may be different, which leads to a different result. The position of a crocodile clip leads to the different result. The student find that during the experiment, the wire become hot because of a high current. She decide to use a variable resistor, complete a circuit diagram, show how variable resistor used for this purpose in the experiment. And same circuit you have to draw, but a variable with a variable resistor. This is the original circuit. I just showed you original circuit. Ammeter is there, a crocodile clip, a wire is there. Now, student want the same circuit. Student want to use a variable resistor. So how you will complete a circuit with a variable resistor and all. Can use the screen annotation to complete this. Yes, so variable resistor is there. And ammeter was there in the beginning, so that will remain ammeter. Then a crocodile clip. Yeah, that's right.